What's up, guys? How you all doing? Hey, welcome to another video on our herb garden. We're going to be looking at how the thing is wired up and how it is coded. So hopefully I can get through this fairly well. I've been kind of sick here lately, getting over it, so I've got a little bit of crud. So if I have to cough, I will try to mute the microphone. In any case, got my water set up, so let's get into this. What we're going to be doing is we're going to be using the Intel Edison. I know I've got an Arduino shown here, but we will actually be using the Intel Edison and using the Arduino compatible libraries and functionality of that. So that's why I've got basically an Arduino showed up. So basically how you hook up an Arduino is how you're going to hook this guy up. So we're going to use a few different sensors from the Seed Studio. I don't know if those of you that don't know what that is. Let me see if I can bring it up real quick. It's actually a pretty cool little thing. What it does is there are many different sensors. Studio, see if I can bring this up real quick on my other screen. There's a number of different sensors that you can buy from these people, and they just plug right in. They have their own shield. It's actually pretty cool. I think you've seen it in other videos I've used, but here's their main wiki page. But look, here's all the Grove sensors that they have, and that's basically the sensors I'm going to be using, is the Grove sensors. So there's a whole slew of them. Obviously, you can see the ones I've clicked on. But anyway, this will tell you, it's actually very cool. Like if the moisture sensor here, it'll definitely tell you how to hook it up, how it works, even give you some sample codes. Really slick resource. So I say if you have one of these Edisons, or really even an Arduino, it'll work with Arduino too. This is a very good solution, and that's basically the kit that I got. This whole video was spawned by Instructables. They were doing another series on these kits. They'd mail out kits. Some were robotics kits, some were agriculture kits. That's the one that I got, and some were other kits that they wanted to make certain things out of. So that's what we're doing with this. But that's basically the sensors we're going to be using. They're going to be all from this list. So if you want to check that out, I'll probably put a link in this down in the description. So let's get rid of that. All right. So sit back, relax, and enjoy. Get a coffee or a beer or a water or something, because this is probably going to be a fairly long video, because we're going to go through the wiring, which won't take very long. As you can see, it's pretty simple, and then we're going to go through all the code, which the code is probably going to be extensive. So get ready, and here we go. So we've got the Arduino Leonardo here, which is basically going to represent our Arduino connections for the Intel Edison. We've got a temperature sensor. We've got a button, which is just a little push button. We've got an LCD display. We've got a soil sensor, and we've got a flow meter. And we also have a relay that will turn the pump on and off to pump water from our water reservoir to the plants. So how this works, very simple. If you have the shield for this guy, they just plug right in. We've got the temperature sensor. Looks like it's wired up to analog number 2. Looks like we've got the switch button. He is going to be wired up to, let's see where we got him going. Signal. He's going to be on D3. We've got the LCD display. That's an I2C display, I think, or maybe it's just SCADA. No, it's I2C. It's an I2C, so it's got the data and the clock signals. Those go over to the standard data and clock signals on your Arduino. So actually, I take that back. This is SPI, so this is serial peripheral interface is what this is coming in as. So we've got that. We've also got the soil sensor. He comes over, or he's an analog output as well. And the flow meter, which the flow meter actually gives you a pulse is what it does. It actually gives you like a PWM wave as it's moving, and basically the faster that the water's flowing through it, or basically the more water that's flowing through it, the faster it will spin, the wider the width on the pulse will be. So it affects the duty cycle of the pulse width that's coming out of it. It is, however, an open collector. type of source, which means that it does not have its own voltage signal that comes out of it. It's basically just a transistor to ground is basically what this is. So as you can follow the signal over, we have to pull that signal to a high, pull it up to 5 volts. I used a 10K resistor. You could use a 1K or something like that if you want a little stronger pull up, but I found that the 10K works just fine. So that pulls that high, and then basically as the sensor turns, it's a Hall effect device is what it is. So as that sensor is turning and passing the Hall effect sensor, it is going to be turning on and off that transistor that is pulled to ground, which will then pull the signal either to ground or let it pull it up to a high based on what's going on. So that's coming into our digital 13 pin. And then we have a relay hanging off our digital 4 pin. Basically, you turn the pin high or low, it clicks the relay or energizes or de-energizes the relay. So that's basically the setup. Very straightforward, very simple. The Arduino stuff just makes things really easy since it's Arduino compatible and whatnot. And so we've got that hooked up. So now let's go ahead and check out the code. This is where the length of this video will be, because the code is quite interesting. In fact, that looks really, really small. Let's see if I can increase this. Let's go to preferences here real quick, and let's make the font in the editor like 18 or something like that. Okay, there we go. Hopefully you guys can see that a little better now. In any case, here, you know what? I aim to please. Let's make it a little bit bigger. Let's make it 20, just to make sure that you guys can see it on your YouTube displays and whatnot. So first of all, we're going to include some stuff. We're going to include the wire.h library. That needs to be included for any time you're going to be messing with the Intel Edison. The setup for the Arduino is actually pretty easy. There is an Edison on there, and this is the new version. This is the 1.64, or at least at the time of this video, it's fairly new. You can go in, if it does not show up in this list, you can go into this boards manager. It's actually kind of cool. And you can select which boards. Since a lot of things are doing the Arduino compatible thing these days, Arduino has now started incorporating it into their stuff. So see, like boards include the Edison. So that's the one. You'll just click on it. Like right now I have remove, but it'll say install. And if you install it, it'll install this board, as well as I think it comes the Galileo. If you have a Galileo, it'll install that. And then you'll be able to go into your boards, and then you'll be able to choose it from the list. So you'll choose Edison. Now, I don't have mine plugged in right now, but if I did, you'd have the port. So you could choose what port, so you could program it, and all that jazz. And that's how you set up your Arduino interface for it. Fairly simple, fairly straightforward. And so here we go. So now the code, wire.h. That's the one that you have to include, like I said, for the Intel Edison. Then we've got the LCD header file for the LCD screen. That's in there. And that you can download from that Seed Studio page that I showed you, that wiki. It has a link on it that will take, and I'll put that in the description. It has a link that will take you to the download. I think it's a Git repository where you can download the code for the LCD screen. And then I'm also including the math.h because we're going to be doing some formulas and whatnot for calculating the temperature. Since that just uses basically a PTC or whatever it is, or, well, not the PTC, but you know what I'm talking about. The temperature sensors are on those logarithmic scales or whatever, so we'll need the math library. So first things first, you need to declare all your variables and define your pins and everything. So we've got the relay on pin 4. We're going to go ahead and declare RGB LCD. We're going to declare, I believe that's its own class is what it is. So we're going to declare LCD as our LCD variable so we can control the LCD screen. We've also got our moisture sense pin, our Hall effect sensor, our button that we push, which I'll show you what that button's for later, and our temperature sensor. All those defined, okay? Then we come down and we set up with this LCD screen. It's actually kind of cool. The backlight is actually an RGB LED. So you can choose what color you want the backlight of the display to be, which we had some fun with that. I changed the color up here and there depending on what mode it's in. So that's kind of nice. So anyway, so we set it up just a nice green color. Since this is an herb garden, we'll set it up as a green in the normal standard display. Then we also set up our variables for our moisture sensor because we want to save that moisture value while it's going into its interrupt routine. This is going to be interrupt driven. We're going to be doing interrupt service routines, or ISRs, because to calculate the flow rate, because we have to do that based on when the rising edge is of the pulse width signal that we get from the sensor. So you'll see how that works here in a minute. On down, we've got variables for the flow sensor. That's down here. We've got the number of they say tops fan. I stole this code from their test code that they had, so I didn't change the variable name. So I'm guessing that's number of tops fan. I don't know. Basically, it's the number of pulses you get. Is what that is, measuring rising edges of the signal. So it's the number of pulses you get. I've got a Boolean value for water level, because what I'm going to do is if we get a really low, like ridiculously low flow rate, then that probably means that our bottle is out and it's just sucking air. So I want to know that. So that's what that Boolean's for. Here's our calculation value. We're going to basically calculate the how many seconds it's going to take to transfer an amount of liquid from the reservoir to the actual garden. So that's what that variable's for. We also have our temperature sense variables. There's a B constant that's in there. We also have a resistance value we have to calculate, because remember, it's a thermistor, basically, is what it is. So it's going to have a resistance value that we have to, according to a chart, basically, or a formula, we have to convert that resistance value to the actual temperature. So that's what that's for. And I believe that's what that B value is for as well. So now let's get into our setup. So in our setup, we're going to initialize our pins, okay? So we've got the relay as output, Hall effect sensor as input, and the button pin as input as well. We also have the interrupt, okay? Now, for the Intel Edison, it's a little bit different than an Arduino. An Arduino has only so many pins, can be interrupt driven, and they have a mapping. There's like a mapping matrix that you can download that will map and tell you which pins map to what mapping number, and you'll put the mapping number in as the first argument in here. Well, on the Intel Edison, it's different. The way it works is whichever pin you're interrupting on, that's the pin number you need to put in. So that's why, notice I have the Hall effect sensor, which up here, where are we at? Hall sensor is basically pin 2, is what I'm saying. Well, down here, where are we at? That's basically what I'm putting in here. Now, if this were an Arduino, like an Uno or something like that, which you could totally use, this code is completely compatible with Arduino stuff, but you would have to change this. This is one of the only things that wouldn't be compatible. You'd have to change this to the appropriate pin mapping that the Arduino recommends for pin number 2 to be interrupted on, whereas the Edison, you don't have to worry about it. Then you've got what function, which I've called it the RPM function, what function you want to run, essentially. What do you want to do when this interrupts, whenever you get an interrupt. And then lastly, what are you interrupting on? Well, we're interrupting on the rising edge of pin 2. So as pin 2 is rising, it will interrupt, and basically what it does is, all it does when it interrupts is it just goes and runs whatever we put into this function. And I'll show you this RPM function later. That's later on in the code. So anyway, after we get the interrupt set up, we want to tell it no interrupts currently, because we don't want anything to interrupt, because whenever it interrupts, it leaves like this section of code and goes and runs this guy. Well, sometimes if you don't declare, that's the reason up here I declare the variables as volatile, okay, is because there's a stack that goes on with an interrupt service routine, and you have to push all of your pertinent data or data you want to receive or you want to save to a stack, which is a location in memory that is not volatile, that it doesn't go away. It's like NVRAM, or non-volatile RAM. It'll push it off to a piece of flash memory instead of the running memory, so that way it doesn't get overwritten or forgotten, essentially, when it moves, because basically it changes focus to the RPM. And so it'd be like if you had variables declared in your loop function, those variables would get overwritten. The same thing with even if you declare them outside the scope out here, they would still get they'd still get lost. So any variables that you need to remember when this thing interrupts, then you need to declare them as volatile. You want them to be volatile variables, so that way it pushes them onto the stack. So that way, when it comes back after it gets done reading or doing this RPM function, it'll come back to wherever it was at when it interrupted and continue running the code. Well, you don't want those variables to be blanked out. Certain variables you don't want to be blanked out, so it'll actually pull those back out of the stack and re-put the values back into those variables as it continues to run. So hopefully that was clear. The explanation was, it'd be better if I had something to draw on to show you, but that's basically what it does. So any variables you want to save, at the time when it interrupts, you want to declare them as volatile variables. That way, this interrupt service routine function or whatever this is will actually push that onto the non-volatile stack and then pull them back out once it resumes where it was at after the interrupt. So we're going to turn interrupts off right now, so that way we don't lose anything or try to interrupt while we're setting everything up. We want everything to be set up first and then begin running everything. So here we go. The next set is we're going to set up the color of the RGB. So that's that color RGB thing. It's up here, the default color. We're going to set up the color, set it to green. Then down here, we're going to print out just kind of like a little splash screen. Auto herb garden, delay 5 seconds. And then we're going to clear out the whole screen and set up our main screen, which is going to have the water level, the temperature in degrees Celsius, and the soil moisture level, whether it is wet or dry. The water level will either be okay or not okay, or low. I think low or okay is the water level. And then the temperature, well, it just displays the temperature off of that temperature sensor. So now we've got that all set up. Oh, and lastly, there's this little piece. This will be covered in another video. I'm going to leave this commented out right now, but I will cover this in another video because this video is going to be really long. But what I've done is I've created a script and whatnot to execute and run. If you have that weaved Internet of Things smart plug, that little guy that I reviewed and did videos on a little bit ago, you can use that to control some grow lights for your automated herb garden. So that's what that's going to be for. I'll show you that again in another video, so that way this one isn't so long. But that's what that is. Right now it's just commented out, and that's all you would need to do if you download this code, is just comment that out that way, or leave it commented out. That way it's not trying to run this script if you don't have it. So now we're going to go down to our loop. So our main loop here, we're going to come in here, we're going to check the water level, or I'm sorry, check to see if the button is pressed. Now what the button I've used for is to reset the water level. Basically, if it sees that the water level is low, it's going to lock out all watering until the water has been refilled. Well, I was going to use the water level sensor for that, but the problem is that water level sensor really isn't that great, because even if the water level got low or something, that sensor stays wet. That sensor would have to dry out before it would actually register that it was low. And the same thing, and it works really well if the water comes up and touches it, because then it instantly will read, a close or whatever is how that sensor works. And so, but since if the water level gets low and it has to dry out, well, it takes longer than what I want. You would have the pump sitting there running and running and running and running, and nothing would be happening. So I didn't use that water level, or I didn't use the water sensor for this. I just used the water flow meter and flow rates and whatnot. So what you're going to have to do is you have to tell it that you've put water back into it, because it doesn't have a sensor for it. So you fill up the reservoir, and then you'll push this button, and due to the way we're looping and the different delays we have, it's basically for about 5 seconds. You hold it in for about 5 seconds, and then it'll reset. And I'll have a demo of all this before too long, and so you'll see how it works. But that's what this checking is for, is it's going to check that button. So we're going to look to see, we're going to set the water level equal to false, and then we're going to do a digital read of that pin, of that button. If you pushed it, basically if you push in the button, it's going to do that, and it's going to wait till you let off of the button, is what this while statement is for. So it's going to say while this is true, basically you have it pressed. It's just going to sit there and loop indefinitely. And the minute you let off of it, it'll stop looping and continue on. That's what that is. And then we've got our water level indication on the display. So that's what this is checking that water level variable, and basically will display okay, or it'll display low based on what the water level is. And this variable is set by many different things. The water level, whatever it is, the water level or watering cycle function will set it, as well as you saw that up here, if you push the button and it resets it back to false, that the water level isn't a problem. So that's basically how that works. So that sets up the display of that. go on down to read the moisture content. So here we are doing the analog read. We're going to read the analog pin, get that into the moisture value. And then based on that value, we're going to look at a saved moisture value, which usually it's 0 now initially, and then as it's looping, it sets it. But we're coming here and say if it's greater than or equal to 0, okay, then the moisture value is less than 298. These are just numbers that I found. You can play with these. It has lots of hysteresis in it or whatever, based on how dry or how wet the soil you want it to be. For me, I found these numbers to be good numbers. So basically, if it's in between 0 and 298, it's going to register as dry. So we're going to set that on the LCD that it's dry. We're going to wait 5 seconds, and we are going to check the water level really quick. And I may even reduce this 5-second thing, because what I'm doing is I'm giving it a little bit of a delay. I may reduce that and take that out of there probably. I don't know. It's something fun to play with. Then we're going to go down to check the water level, make sure the water level isn't low. And if it isn't low, then we'll go ahead and initiate a watering cycle. Then we're going to check and see if it's wet. If it's wet, then we're just going to, that's the else to this. So else, if the moisture is between 302 and 700, then we're going to say that it's wet, and we're going to be done. If we can't read a reading, if it's outside of any of those ranges, then we're going to just say, TBD, to be determined. We don't really know. We're not going to display anything. And that's always a good rule of thumb in programming on your else's and whatnot, is if you get bad data, it's best to not display anything than display bad data. So basically, if your program is unsure, it needs to just not display anything. So that's basically what we're doing. We're putting to be determined. Basically, I don't know. I don't know what the status is. The sensor may be bad or something like that. It could be, it's got a short in or something, so it's way outside these ranges. So to be determined, we don't know. That's our else. And then we save that moisture value that we've read for the next time. So that way we can do a comparison as we're doing here. All right, so now we go down to our temperature sensor. So here's our temperature sensor. We're going to read the analog of that temperature sensor. We're going to typecast it to a float. Okay, that's what this is doing. This resistance is a float, so we're going to typecast all of this into a float. So we've got the formula. This came straight from the Seed Studio website through that Wiki. They showed exactly how you calculate this, and that's where I got this calculation from. So what all these numbers actually mean, well, you can go in there and pull up the data sheet and everything and look at it yourself if you're curious. But see, here we have to use log, because like I said, most temperature sensors are on a logarithmic scale is how that they work. So we've got log functions. Well, that's the reason we need the math.h library, is because we're doing logarithms and things like that to calculate the temperature. And then simply enough, we just display it. That's what we're doing there. And then this whole thing takes about a second. We delay a second and then run that loop. So now on down to our custom functions. Here is our interrupt service routine, the RPM. Whenever it interrupts, remember that up here in the setup under interrupt, we have RPM is the one that we're using. So whenever we interrupt, essentially when we enable interrupts, which was, let's see, where was that at? Well, that's going to be down in here. You'll see that here in a minute. It's down in the watering cycle where we'll enable interrupts to read the flow sensor. When we iterate that, what we're doing is every rising side of the pulse, we're basically going to count it. That's what this is doing. It's adding one to this number of top stops or whatever, top fan stops, whatever it is. We're going to be adding one to it. So we're going to count how many pulses we get in 1 second. And you'll see that later that we'll do 1 second. Excuse me. Had a hiccup. You'll see that later that we'll do it will be for 1 second. Okay. So that's what that'll be for. So that way every pulse, and that's basically the frequency, right? So that's what we're calculating is the frequency of our pulse. It's how many pulses we get in 1 second. That's exactly frequency, because right, 1 over the frequency is the time. So that's what we're doing. So we're going to count how many pulses we have so we can do it with our calculations. So that's all there is to the interrupt service routine. Very, very simple. Now we come into our watering cycle. This is where things get a little complicated. We've got a counter variable. We've got the flow rate that we've set as a double so we can have decimals. And then we're going to clear the LCD screen out, and we're going to display that we are in a watering cycle and that it is active. And we're also going to change the color to a blue, red, green, blue. We're doing 255 on the blue, so we're going to get a nice dark blue color. And then we're going to go ahead and we're going to turn on the relay. So that's where we write a high. We're going to wait 2 seconds. And the reason we wait 2 seconds is maybe your system has run out of water at one point in time. So all the pipes are basically without water, and well, they need to be primed and everything like that. So we wait for the water pressure to come up, the pump to get the water flowing, the pressure to come up, and so that way we can get an accurate measurement of the flow rate, because if you have air in the lines or something like that, it can throw off the measurement. So we wait a couple of seconds so that way it's nice and full of water and the water's pumping at the speed that it's going to be, the motor is up to speed and everything. Then what we're going to do is we're going to initialize our number of, our counter variable. And then we're going to turn interrupts on, and we're going to wait 1 second. Well, within that 1 second, obviously we're going to have rising edges, right? So in that 1 second, it'll be interrupting, okay, and adding and counting using this variable, counting how many impulses or, rising edges we have. Then we're going to turn the interrupts off after that 1 second, and then we're going to go ahead and calculate our flow rate. And that's what this guy is. This 73 is the actual number that comes from the data sheet of the flow sensor. I actually had problems because I had the wrong data sheet. It was 7.5, and I was getting all kinds of wacky numbers coming out of that, and that was because I had the wrong data sheet. So make sure and look at, and where I found the error was in that Seed Studio, that Wiki page. I looked that up and saw that in their example code they had a different value there, and I looked it up, and it was because I was looking at the wrong flow sensor originally. And so once I got the right flow sensor, it has the formula in the actual data sheet. So I'll let you guys look that up. And so that's what that is. So this calculates the flow rate for this particular sensor. Okay. Then down here, what I want to do is I found that watering about 500 milliliters was perfect for my garden. Your garden might be different. If you have a bigger garden or something like that, it may need to be a whole liter or something like that. But basically, that number is going to go right here. And it's going to be in liters. So if it's 500 milliliters, that 500 milliliters is half of a liter. So it would be 0.5 liters, okay? Because the flow rate is calculated in liters per hour, okay? So what we're doing is we're taking the flow rate and we're going to convert it to liters per second, okay? 3,600 is how many seconds are in an hour. So we're changing hours to seconds by dividing by 3,600. Then we're taking that whole flow rate and we're dividing our 500 milliliters by that to get the time, to get how long should we have the pump open or on, basically. So that's what this is doing. Calculates the amount of time in seconds to pump 500 milliliters of water. So if you guys in your gardens need more water or less water, you just change this number right here. But just remember, it's in liters. So if you want milliliters, you have to do, you have to move the decimal 3 places to the left if you're wanting milliliters, okay? So that's what you got to do. All right. So then we calculate how many seconds or number of seconds it's going to take to pump 500 milliliters. We store that to our counter variable, and then we check and make sure that the water level isn't low. And then we go down into here and we set the time. We set our timer up and we say, all right, we're going to show you how much time is left. We're going to print our I variable, our counter variable. And then what we're going to do is we're going to take and set our number of fan stops to 0, delay 1 second so we can calculate the flow rate. What we're doing here is we're constantly calculating the flow rate. Right here is going to do the same thing to make sure, and it will break out of this loop and stop watering if the water level ever becomes low. So basically, if you're sitting there pumping along and your reservoir is at the bottom and you're pumping along and you have like 30 seconds worth of water to pump, it's going to basically dry up the reservoir, right? Well, you don't want it to sit there sucking air, because I don't know if this pump looks like it's probably fine, but some pumps need the water as a lubricant, so you can actually burn out the pump if you don't have water flowing through it. So this is basically that safety type of the situation. Basically, we don't want the pump running if no water's going through it. So we're going to check continually as this is cycling. We're going to check to see if the water level ever gets low. So that's what that is. And then if it does, we're going to just break out of this loop, stop this whole operation, and go back to the main screen. So now we're going to come down here, and since we waited a second, basically it's 1 second per count, we're going to basically minus 1 from the counter. So the counter is going to, and we're going to count till it's, we're going to keep doing this while it's greater than 0. The minute it becomes 0, basically the time runs out, it's going to jump out of this loop. Unless the water gets low while we're in it, then it'll jump out due to the water being low. So that's basically it. Well, the minute it ends the loop, it's going to stop the relay. It's going to turn the relay off, which will turn our pump off. Okay. And then we're going to come down here. And what we're going to do is I put in a delay because that soil moisture sensor, if you sprayed water all along the top, the water's got to soak down into the dirt. So if we immediately started reading the soil temperature, you'll probably see that it is still dry because the water hasn't soaked through the soil to wet the sensor yet. So we want to wait a little bit. Otherwise, you're going to be dumping tons and tons of water till the sensor finally gets wet, but you could have dumped way too much water by that time. So we're going to let it soaks. So that's what this is. So as long as our water level is good, we basically didn't have to bail out up here. We're going to run the soak cycle, okay, which is just 30 seconds, and it has a little cursor that moves across the screen, kind of like a status bar is what this whole code is for. But it's basically going to change to soak up here. And when it changes to soak, it will wait 30 seconds, okay, show you a little status bar, and then it will revert back to the original display, which when it finishes that, we will come all the way back to our original setup, okay. Let's see, find where I'm at. That's watering cycle still. It's going up. So it's going to come back to here. That function will finish. It'll go down, save the moisture level, loop back to the top, and basically it'll check again. It'll loop back to our loop. It'll check the button. It'll check the water level, and it'll check the moisture level. And that's the main thing, is it'll check the moisture level and see if it's now dry or wet after 30 seconds. Now, if it ever does run out of water, like I said, it will set this water level to true, which then will be looking at that. We'll be looking at that button. We'll check the button to see if you've pushed it and reset it yet. If not, it's going to come in here and it will not do the water cycle. It'll check the water level. If it's true, then it'll just skip this. It won't actually do a water cycle. So that's where you'll fill it back up with water and you'll push the button. It'll see that the button is pushed. It resets the water level to false and everything takes back off. So that honestly is basically the code section of this. Fairly simple, fairly straightforward. We'll probably have a demo of this probably at the end. Like I said, I will cover that weaved portion, that weaved Internet of Things little device, this section. I'll cover this in another video because I guarantee this one is definitely long enough. I've talked for quite a while now. So guys, hopefully that helps. I will post this code on my project code link. Make sure and go to that and check it out if you want to take a look at it and everything. I will, once I do the other video, I'll post all the other software and scripts and whatnot that I have running on the Linux devices and whatnot. So I'll post all that on the second video. But for right now, this is the code for the automated herb garden currently right now, just without any of the Internet of Things devices connecting to other devices for the grow lamps and whatnot. This is just moisture level, content, temperature, and flow rate and whatnot is what it's checking for, as well as displaying it all on the LCD screen. So guys, I think my voice is about done. Hopefully you guys enjoyed this. Like I said, there'll be another video out. And ultimately, when this is all over with, I will have a full Instructable written and posted on Instructables. So if you haven't checked me out on Instructables, add me there, follow me there, all that, as well as follow me on Twitter. I try to take pictures of things like this, these big projects. It's been a while since I made a video because I've been working on this, and I try to post them on Twitter so you guys kind of know that I'm still working on things. I haven't just totally left the YouTube scene. I'm just working on something that's taken a while and don't really have time to do anything else other than this. So check me out on there. That's how I communicate with everybody. Make sure to like, subscribe, share, all that jazz. It really helps out the channel. I'm getting ready to place an order for some more stuff for us to play with. After this gets over with, we'll start some other projects. In fact, there'll be a Halloween special coming up now that we are in October, so be looking for that. And guys, I have rambled long enough. Take care, guys. We'll see you next time. And with that, that ought to do it. Take care.